Hello, my dear students. This is Mrs. Suhair Zaki, and we will start our second part in our first lesson in science curriculum for second prep students. Let's start. In our previous lesson, we started the understanding of the states of matter, and now we are continuing our lesson. In our lesson today, and by the end of our session, you will be able to use particle theory to describe the behavior of matter in its solid, liquid, and gaseous state. Also, by the end of our session, you will be able to explain some physical properties of matter in different states in terms of particle theory. And the second point in our lesson objectives today, to appreciate the role of scientists in discovering the plasma state and its application. We will start to understand the particle model of matter. Here are our three states of matter that we have learned in our previous session. They are, of course, solid state, liquid state, and gaseous state. So let's imagine ourselves in a journey inside the matter, wandering among the tiny units called particles, as each state of matter consists of particles. The solid state consists of closed particles. Liquid state have wide spaces between its particle, while gaseous state have very large spaces between its particles. So we are going to imagine particles as tiny spheres, like here in the figures. So the particles are tiny spheres that make up everything around us, such as water, air, and blocks of metals. So we will imagine the constituents of each state of matter of tiny spheres. These tiny spheres are the particles of the matter. What does make the properties of matter vary depending on its physical state? Why the properties of solid state differ from the properties of the liquid state, and the liquid state properties differ from the properties of the gaseous state, and so on. We have learned in our previous session, for example, that solid state has fixed shape, while liquid state and gaseous state have no fixed shape but take the shape of the container. So why the property of each one of them depend on the physical state of the matter? This we are going to discuss and learn in our session. We can explain many of the physical properties of matter in terms of the behavior of its particles. So the properties will depend on the behavior of the particles of the matter in each different state, and this will explain the physical properties of the matter, from being have a fixed volume or a fixed shape or fluidity or compressibility, as we have learned in the previous session. Let's remember together our cumulative knowledge. The first point, the particles. The particles can be monoatomic or polyatomic molecule. What is meant by monoatomic molecule? Monoatomic molecule means that the particle consists only of one atom. while polyatomic molecule, that the particle of the matter consists of two atoms or more than one atom. In this case, we call the molecule polyatomic molecule. So monoatomic means only one atom. Polyatomic means many atoms, more than one atom, two atoms or more. The second point, polyatomic molecule is formed by the bonding of two or more atoms together by chemical bonds. We have learned that the chemical bonds could be ionic bond or covalent bond. So the atoms linked together in the polyatomic molecule by chemical bonds to form the molecule of this matter. Scientists always try to explain different natural phenomena by making assumptions in an attempt to understand how things work. When these assumptions succeed in explaining many phenomena, they become a scientific theory. So, what is meant by a theory? A theory means that the scientist explain a phenomena by making assumption and try to prove this assumption, and when the assumption succeeded, they become a scientific theory. So this is how the scientific theory is made up. الثيوري معناها نظرية، والثيوري بتتعمل ازاي؟ لما الساينتست بيعملوا assumption، بيفترضوا فروض، والassumptions دي succeeded، فلما بيحصل succession للassumption بتبقى دي الثيوري. So scientists explain the phenomena by making assumptions and examine these assumptions, and when the assumptions succeeded in explaining this phenomena, the assumptions became a theory. One of the most important theories that has succeeded in explaining much of the behavior and properties of matter is the particle theory of matter. So we are going to study now the particle theory of matter. What are the assumptions of particle theory of matter? Let's start by the first point. All matter around us is made of particles like these spheres in the figure. So these particles of solid state of the matter, and these are of the liquid state, and the last one for the gaseous state. So all matter made up of particles which are so tiny and cannot be seen by naked eye. So we cannot see the particles of the matter. This is assumption that the scientists put it to explain the behavior of the matter and the different state of the matter and the properties of each one of them. In different materials, particles of the same substance are identical. This means that if we have methane particles, for example, like here in these photos, methane molecule consists of one carbon atom and linked to four hydrogen atoms. Each methane particle consists of the same number and the same types of atoms. So when you examine any molecule of methane or any particle of methane, it will consist of 5 atoms, 1 carbon and 4 hydrogens. And the same here in carbon dioxide. Each carbon dioxide molecule consists of one carbon atom linked to 2 oxygen atoms. So they are similar in the same substance, but if we compare methane and carbon dioxide, it will be different in different substance. So particles of the same substance are identical, but their types differ from one substance to another. So the particles are different from methane to carbon dioxide. But in carbon dioxide, particles are all the same. Methane particles are all the same, and so on. There are attraction forces between the particles of a substance, and the particles store potential energy due to these forces of attraction between them. The attraction forces between the particles gives the state of the matter the properties like fixed volume or definite shape or fluidity and so on. So the attraction forces between the particles existed and lead to the properties of the matter in its different states. Here are the three different states of the matter: the gas, liquid, and solid. There are interparticle spaces between the particles of the substance that vary depending on its physical state. Interparticle spaces means the spaces between the molecules or between the particles. So in solid state, the particles are very close to each other, only very tiny spaces between the particles, while in liquid state the interparticle spaces became wide. So the liquid particles became apart from each other. In the gaseous space, the particles of the medium have very large interparticle spaces between them, and so the physical state of the matter determines the interparticle spaces between the particles. It's very, very tiny in solid, it's wide in liquid, and it's very large in the gaseous state. Okay, let's discuss another property of the matter according to the state. The particle of the substance have kinetic energy. So they are in a continuous motion in straight lines. But this motion will differ according to the state of the matter. In case of the solid state, the particles are very close, like here in this metal cube. In the liquid state, the particles have wide interparticle spaces. In the gaseous state, the particles are very apart from each other, or have very large distances between each other, and this will affect the motion of each state of the matter, as we are going to observe. The way the particles move and their speed differ depending on the state of the matter. So we will observe that in gaseous state the particles are moving very fast. In liquid the speed is less than the gaseous state, and the solid it will be only vibration in its place without any recognizing of the motion of the particles of the medium in the solid state. We are going to explain more in our session. As we mentioned before, the forces of attraction between the particles of the different states of the matter will affect directly on the properties of the states of the matter. So the attraction forces will be strong, very strong in solid state, will be less in liquid state, and will nearly not exist in the gaseous state. And the attraction forces will affect each state of the matter. Let's start by the solid state of the matter. In the solid state, the forces of attraction between the particles are very strong, so they are tightly bound together. They are very close. The attraction forces are very strong, so They have fixed shape, they bound together, they are attract each other, and so the solid state will be in a fixed shape and fixed volume. The interparticle spaces are very small in the solid state, of course, as we mentioned before, so the particles cannot move from their position. But the motion in the solid state only vibration in their fixed position without moving to another position. And so the solid materials cannot move from one place to another, cannot change its shape, because they are very close to each other, the particles are very close to each other, the interparticle spaces very, very small, and the attraction forces very strong, so they cannot move, they only vibrate in their fixed position. So the solid matter have fixed shape and fixed volume. So if I asked any student why the solid matter have fixed shape or have fixed volume, you will answer this question by the attraction forces are very strong in solid state. The interparticle spaces are very tiny, are very close, they are very close to each other, and so the motion only vibration in their fixed positions without moving from their places, so the solid matter have fixed shape and fixed volume. Let's move to the second state of the matter, which is the liquid state. In the liquid state, the forces of attraction between the particles are relatively weak, so it's weaker than the solid state. In this case, the particles can move more freely, but they are sufficient to hold them together. They can move freely, but still in the container without leaving the container. As you can see in this animation, the particles can move more freely than the solid state, but still being together in the container. And this is why, as the interparticle spaces are relatively greater, this explains the ability of the liquid to flow and take the shape of the container. If we have, for example, a certain volume of a liquid like this blue liquid, and put it in different containers, each container will make the liquid take its shape. As you can see, this is round, and so the liquid looks like round. This is conical flask, and so the liquid also becomes conical, and this is the test tube, and this is the beaker, and in each container the liquid takes the shape of this container. In gaseous state, so we are moving now to the third state of the matter, which is the gaseous state. In the gaseous state, the forces of attraction between the particles are very, very weak. So the attraction forces here very, very weak. Let's see what will happen in the gaseous state according to the weak attraction forces between the particles. As you can see, the gas particles move randomly and completely free. The gaseous particles move in all directions, completely free. The attraction force is very, very weak, and the space is very large between the particles of the medium. When relatively large particles are present in fluids such as dust in air or pollen grains in water, this animation will take place. and we are going to study this phenomena in our coming slides. When dust becomes in air, and every one of us can observe this phenomena. لما يكون في تراب في الهواء بيحصل يعني انتشار للتراب ده في الهواء أو حركة motion للdust particles in air, and this we are going to explain in our slides in our session today. Collisions occur between the molecules of the fluid and these particles, making these particles move randomly in all directions. Why the dust moves in this way in the air? Collisions means the particles of the air and the particles of the dust collide to each other or hit each other. البارتيكلز بتخبط في بعض، فلما بيحصل الكوليجن ده the particles move randomly. بتبتدي البارتيكلز to move in all directions. This is the observation of the movement of dust particles in the air. This phenomena is very important, and the collision occur between these particles of dust and air particles is explained by Brownian motion. This concept is very important to us. Brownian motion, named after the scientist Brown, who discovered this phenomena. So this is the Brownian motion phenomena, and that what will happen when the dust being exists in the air. The collision between the particles of dust and the air particles make the dust moves in all direction in straight lines, and this is called Brownian motion phenomena. So remember this name in our lesson today. This explains the ability of gas to diffuse and the shape take the shape and the volume of the container. This allows the particles of gas to take the shape of container as they move in all direction in a straight line very freely, as we have explained the Brownian motion phenomena, and so they take the shape of the container. Also, we have learned in our previous session that gas is characterized by the compressibility, and so when we press the piston, the particles of gaseous materials becomes very close to each other and its volume decreases. So, as the large interparticle spaces between gas particles allow the volume of the gas to be reduced, as you can see in this animation. By increasing the pressure, by pressing on the piston, the particles becomes very close to each other, and the volume of the gaseous state will decrease, but the size of particles will be remains the same and without any change in its size. The particles, the red particles, remains in its size, but the gas itself, the volume of the gas itself decreases as we press on the piston and the pressure increases. Here are some cross-cutting concepts: cause and effect. They are related to each other. The cause will lead to the effect. The difference in the forces of attraction between the molecules, this is the cause that we have learned during our lesson, leads to the differences in the properties of the matter, and this is the effect. So, as we have explained in our lesson, the force of attraction between the molecules cause the variety and the change and the differences between the properties of the different states of the matter. So in solid, for example, the attraction forces are very strong between the particles, and this causes the solid particles being very close to each other and hold each other tightly, and there is no change in the volume for solid state and no change in the shape, and so on. The forces of attraction will be less in the liquid state and very weak in the gaseous state. And now let's design a particle model of matter structure. And this we are calling scientific and engineering practices. So let's try this together. Modeling is a way of presenting a simplified presentation of objects that are either too tiny to be seen or too massive to be comprehended, which helps us to understand objects and relationships between them. So we are modeling something to understand more. As we have mentioned before, we cannot see the particles of the medium with the naked eye. And that is why we try to design a model for the different states of the matter. احنا مش بنشوف البارتيكلز بعينينا، وعلشان كده احنا بنحاول ان احنا نعمل موديل لل different states of the matter بان احنا نستخدم بعض التولز البسيطة علشان نفهم ال states of the matter that we are going to try to do it in our session. So we will use some tools from our environment, like for example corks or grains such as lentils or rice, or use computer program to work on the models that illustrate the physical composition of matter. Try to use something very simple, like some lentils. Lentils means حبات من العدس. So try to put it very close to each other to make a solid state, and some other grains a little away from each other to resemble the liquid state of the matter, and some other lentils very, very away from each other to resemble the gaseous state. And so by this way you have learned and make a model for the solid state, the liquid state, the gaseous state by very simple tools in our environment like lentils or rice. Or you can do it in your computer. If you have a computer, you can draw circles close to each other and some circles away from each other, and some circles are very apart from each other to resemble the three states of the matter, and to make this model by yourself. And now we are going to evaluate our understanding from our session today. Here is some figures, figure 10, figure 11, and figure 12. Let's try to answer the questions. We will try to answer these questions together. Explain according to the particle theory of matter. Number 1, the difficulty of breaking a piece of rock, figure 10. So this is a piece of rock and this is a hammer, and we will try to break down this piece of rock, and what you will observe when you will try to break this piece of rock by the hammer. Of course, you will observe that it's very difficult to break a piece of rock in figure 10. Why? Because this is a solid material. The attraction forces of the particles are very strong, and so it's difficult to break this piece of rock by the hammer. Number two, the possibility of dissolving a quantity of table salt in water, in figure 11. This lady tried to dissolve a tablespoon of table salt in the water. What will we observe? Of course, the table salt dissolves very easily in water because the particles of the medium will move very fast, and so the table salt will dissolve easily as the liquid state has low attraction forces between the particles of the medium, and they move in all direction. This will make the dissolving of salt very easily in the water. Number three, the reason for the diffusion of smoke from a candle wick in the air in figure 12. When you light a candle and blow its flame, you will observe that the smoke diffuse in the air in this way, like in the figure. So try to mention the reason for this phenomena. Yes, of course. So let's explain the diffusion of the smoke in the air. As smoke particles move easily in air according to, yes, to Brownian motion theory. Let's remember this name and this concept. Very important to remember it to explain the motion of dust in air or the motion of smoke in air. Now we are going to explain one of the most wonderful and important states of the matter, which is plasma state. When the gases are ionized, they are converted into positively charged ions and negatively charged free electrons. So this is called the ionization. When the gas molecule ionized, they convert it to positively charged ions and negative electrons. This state is known as plasma. So this is a state when the ionization phenomena, this state is known as plasma. And plasma is the fourth state of matter. This state characterized by high electrical conductivity, and we are going to observe this plasma state at the poles in a phenomena called aurora phenomena, as we are going to explain. Most matter in outer space exists in the plasma state due to the effect of the sun rays on the materials exist in the space. So the particles of the matter exist in the plasma state, where the matter found in the sun, stars, and the cosmic nebula are in the plasma state. This is how we can observe the aurora, and also plasma state exists in lightning. So this is how the aurora at the poles, which is a wonderful phenomena. We can observe it at the poles of the earth, at the North Pole and the South Pole. And in this phenomena, we can observe how looks like the plasma state, in which the particles exist in as ions, positive ions and negative electrons and cause this wonderful amazing phenomena. Now we are going to study the technological application of plasma state. The plasma state is used in air conditioners, in the AC, to improve air quality in enclosed spaces. Let's explain how the plasma state improves the air quality. The gases are passed through the high electric field to convert them from atoms into positively charged ions and negatively charged electrons, and that is the plasma state. When the charged gas ions exist, they work to break down the harmful air pollutants like germs and viruses, and this makes the air clear and pure. So the air, when moves through the air conditioner, the particles of the medium converted into ions, positive ions and the negative electrons. These ions break down the harmful pollutants of the air like germs and viruses and make the air pure and clean. Now let's evaluate our understanding. Let's observe these two figures, figure 1 and figure 2. The following two figures represent two states of matter. So which of the two figures represent the fluid and what is its state? Let's examine the two figures together. In figure 1, the medium particles have wide interparticle spaces. So we can conclude that the attraction forces here are weak attraction forces, and the motion of particles of the medium are free, so they can move and take the shape of the container. While in figure 2, the particles are very close together, which indicates that the attraction force is very strong, and so the medium particles cannot move, and so they have fixed shape. By studying these two figures, we conclude that figure 1 represents a fluid and its state is a liquid state. Number 2, compare between the states of matter shown in the two figures in terms of number 1, the forces of attraction between particles. Of course, by studying the two figures, we will observe that figure 1 has weak attraction forces, while figure 2 have strong attraction forces between medium particles. Number 2, compare according to the movement of particles. Of course, in figure 1, free motion of medium particles, while figure 2 has its solid state, the movement only vibration in their position without leaving their position. Thank you for attending our session today. Thank you, and waiting for joining you next session, inshallah.